Today we're going to start working with solving equations where the equation has a variable on both sides. And we'll call this example 1. Let's go ahead and write it down just so you can see what I'm talking about. If you'll notice on this problem, this is the first time we've seen an equation where there are x terms, or we call those a monomial, on both sides. Okay, there is a 4x here and a 2x there. What we have to do is we have to put this in your notes. Note, get all terms with an x, or it could be a y or an m, whatever the letter is. Get all terms with an x on the same side. And this is one of the reasons why I've made a big deal out of understanding equation steps, is because I knew problems like this were coming. So the first thing that I should do is I want to move this 2x over here. And remember that we can only combine like terms. So we're going to use an opposite. That is a positive 2x. So I am going to subtract 2x from both sides. Okay, so I'm going to take out this blue line, looks like a fraction bar. Now notice what happens. When I subtract 2x from both sides, on the right side, the x terms go away. And I just have equals 7 over there. On the left side, I need to combine these like terms. 4x minus 2x is 2x. But I still have this minus 3. That is the most important new step to this equation, because everything from there on out we've done before. Okay? From here on out it's pretty straightforward. We add 3 to both sides so that 2x equals 10. And then I finish by dividing by both sides by 2. So the final answer is 5. So the most important thing is getting all of the x's on the same side. Let's do another example. We've got several to do. 2x plus 6 equals 5x plus 18. I'm going to pause the video. You try that one. All right, you've had an opportunity to work on this, and one of the questions that comes up all the time is, should I move the 2x or should I move the 5x over? And the answer to that question is that it doesn't matter. You'll get the same answer. So some of you may have decided to move the 2x, some may have decided to move the 5x. How many of you decided to move the 5x? Okay, more than half of you. So that's the one I'm going to do. I'm going to subtract 5x from both sides. They go away on the right, and now I have negative 3x plus 6 equals 18. And I finish by subtracting 6. So negative 3x equals 12. Divide both sides by negative 3. Your final answer should have been negative 4. And if you decided to move the 2x, you should have got the same answer. All right? So we've got a couple more examples to do. Just different situations that we have not seen yet. Some of them, the variables on both sides, some of them they're not. Let's take a look at this one. 5 times 2 plus n equals 3 times n plus 6. Now what you'll notice right away is that we have a distributive property situation. We need to use the distributive property. So I'm going to distribute multiplication to both. That will make this 10 plus 5n equals 3n plus 18. Once you use the distributive property, this problem is exactly like our last two. All right, from this point on, we do the same things. This time I'll move the 5n over here just to do something different because that's totally legal. I now have 10 equals negative 2n plus 18. Make sure you get the signs correct when you're combining those terms. It's negative 2n. Then I need to subtract 18 from both sides. Negative 8 equals negative 2n. Divide both sides by negative 2. And my answer is 4. All right, so sometimes you may have to use distributive property first and then get everything on the same side. You can see now our problems are longer. All right, this is why I've made a big deal about showing correct steps. We now have 1, 2, 3, 4, 5 sets of equal signs. All right, so it's important to show good steps. Here's our next example, one that you might see something like this tonight. 9 minus 2y over 7 equals y. Now right away you're going to notice that I have a y on both sides. But the good news is we've already seen problems like this, and what we want to do is get rid of this ugly fraction and take that 7 over. So the opposite of dividing by this 7 is multiplying. So let's multiply 7 times both sides. 7 times 9 minus 2y over 7, and 7 times y. We're going to multiply both sides by 7. The reason we do that is because the left side, I put this 7 over 1, and these 7s factor out, and they just go away. They become a 1. So look at the left side now. All I have is the 9 minus 2y. 9 minus 2y equals 7y. And we're getting much closer. Don't I need to get all the y terms together? What should I do next? Add the 2y. We have to get all of our y terms on the same side. So those go away. 9 equals 9y. And how do I finish? Divide both sides by 9. So the answer is 1. 9 divided by 9 is 1. Okay, we're actually getting close to being done here. Just a couple other kind of cleanup type problems I want to make sure you know how to deal with. What if you see a problem like this? Now, the first thing, it's actually a very short and simple problem. The only thing I need to do is write this as negative 1x equals negative 12. That's the only thing we got to do. If you see negative x, it's the same thing as negative 1x. Now, how would I finish solving this? Divide both sides by negative 1. So my answer is positive 12. All right, we haven't seen a problem like that yet, but you're going to see it tonight. One more problem. 1/3 times 12 minus 6x equals 4 minus 2x. Now, the first thing you notice is that I have the distributive property on the left-hand side. So I need to do distributive property 1/3 times 12 and 1/3 times 6. Now that's not as hard as what you think. We've done this. 1/3 times 12 over 1. I do my factoring. 3 divided by 3 is 1. 12 divided by 3 is 4. So this first term, when I do 1/3 times 12, is just going to be 4. Minus whatever I get when I do 1/3 times 6. And you have to put the 6 over 1. So I do my factoring, and you're right, it is going to be 2x, not just 2, 4 minus 2x. Now that's equal to this other side, 4 minus 2x. Now, you should be seeing something strange right now. Aren't the left side and the right side exactly the same? When you see that, watch what happens when I try to get my x terms together. If I add 2x to both sides, don't they both go away? And it becomes, look what's left, 4 equals 4. There's no x term, is there? But the question I want to ask is that a true statement?
Yeah.
Does 4 equal 4?
Yeah.
Okay, this is a true statement. If the variables go away and you're left with a true statement, then the answer is, this is how we write the answer. All real numbers. What does that mean? That means any number I put in for x will work. I could put in 37, I could put in 129, I could put in -8. Any number will work in this equation to make it true. All right? Remember, it is possible to check your solutions on these problems. How would we check a solution? You know, let's just look at a basic problem like 5x plus 3 equals 18. Let's say I wanted to check my solution. All right? If I solved this real quick, and I'm going to go kind of fast, I'd subtract 3, 5x equals 15. I would divide by 5, so my answer is 3. How would I check my solution? If I wanted to check my solution, then I would put my answer back in for x to see if it makes the equation true. So I said x is 3, so let's try it. My original problem was 5x plus 3 equals 18. So if I put this 3 in right here, does 5 times 3 plus 3 equal 18? What's 5 times 3? 15. Does 15 plus 3 equals 18? Yes, it does. It checks out. That means I know my answer is correct. All right? You can always do that. You could even do that mentally if you're careful with it. And that's how you check a solution. And we're going to stop there for today.